morning, guys. We are going to be taking a look at our next section, still dealing with angles, but while the last section just was how to name them and how to classify them, this next section is about comparing two angles. So we're going to be looking at pairs of angles and what kind of angle relationship are they going to make. So let's start over on the left side and talk about adjacent angles. So a couple of main words to get out of here is the idea of adjacent just means that two angles are next to each other. So in other words, they are going to share a common side. So that's kind of our big example to take away here from adjacent. So if we have an example here, let's say we start off with an acute angle and an obtuse angle, and there is a ray that's coming off from that same end point. Well, then we have angle 1. So I'm going to put a little 1 inside this space, and angle 2. These two angles are adjacent. We don't know anything about their measures or anything else about their relationship, only that they do have one side in common, and that is that ray that I just highlighted. So that's making them adjacent. So let's move right along. Let's keep going up and over to the right. And let's look at our next major relationship, the vertical angle. Vertical angles are very specific because we need certain things to happen. First thing we need to have is intersecting lines. So two lines that cross each other. So there's my first line and there's my second. Now, for angles to be vertical, they have to be across from each other. So if I'm looking at, let's say, this top angle space that's here, I'm going to call this a 1, so angle 1. I need to find the angle that is directly across. Now, think about the idea of across as opposite. So if angle 1 is exactly in the top position of these four spaces that are here, I need the angle that is in the opposite position of top, which is the bottom. And so we can call that one, we'll call that one angle 2. So those would be a set of vertical angles. We could also go the opposite direction here. And over on the left side, we'll call that one angle 3. Well, if angle 3 is in the left position, I need the opposite of that, which is the right position, which would be where angle 4 is at. So that one would also be a vertical angle pair. So angle 4. So the last thing that I want to talk about specifically with vertical angles. This is one of our big ones because vertical angles are always congruent. They're always going to have the exact same measure. So whether we're looking at angle 1 and 2, they will have to be congruent because they are in opposite spots. They are across from each other. The same is true for angles 3 and 4. It will be congruent to angle 4. They will be congruent as well, meaning they will have the same measure. So if the angle 1 position was 100 degrees, angle 2 would also have to be 100 degrees. If angle 4 was 80 degrees, angle 3 would also have to be 80 degrees. So moving right along, let's keep going around our outer edge here. Now we're going to check out our next kind of special pair that we will have, which is the linear pair. And there's a special key word here in a linear pair, and this is a word that you know from Algebra 1, which is the line. So linear pairs are two angles that are adjacent, and they have to be supplementary, and we'll talk about supplementary here in just a second. Now, the clue here with these is they form a straight line, which you can also think about a straight line as being a straight angle. And we talked about straight angles on our previous topic and how they have to make 180 degrees for a straight angle. So let's take a look. We're going to look at two examples this time. So let's say you have a line going left and right, and we have a ray coming off from that one. And let's say again, we have angle 1 in the left space and angle 2 in the right space. Well, angle 1 being the left side of this angle, of this straight angle that's there below. And then you have angle 2 on the right side. And check it out. Those two spaces together fit like a puzzle piece. And what they're doing is they're completing this whole straight angle. So then we call them a linear pair because they complete the straight angle, making 180. Now, another way that we can think about linear pairs, if we go back to that idea of our intersecting lines, I'm going to number these off, 1, 2, 3, and 4. We have actually 4 sets of linear pairs happening here. I could do angle 1 and 2. They would make a linear pair. I could have 2 and 3, 3 and 4, 4 and 1. All of those sets make up 180 degrees because they're making that straight angle. So whatever is going on at angle 1 for this first picture, so its measure of angle 1 plus the measure of angle 2, whatever it is, we don't know its value, but we know, oops, sorry, that should be a 2. If we add it to angle 1, it should make a straight angle of 180. Same thing over here for our intersecting lines. This set of angle 1 and angle 2 also make 180. And again, just remember, anytime two lines intersect like that and make that X figure, you'll always have more than one set of linear pairs here. Like I said, angles 1 and 2 make 1, 2 and 3 make 1, 3 and 4 make 1, and 4 and 1 make 1. All right, so let's keep going straight around our figure here. And we have that idea of supplementary. So more specifically, supplementary angles are any two angles that have a sum of 180, whether they are linear pairs like we just saw. So I'm going to get that same picture back up here. So angle 1 and angle 2, those would be considered supplementary. When your lines intersect, so sorry, let's get our pictures back up. So that angle 1 and 2 made a linear pair. We had angles 1 and 2 from the linear pairs also make 180. And sometimes we may just have two angles that aren't adjacent at all. So maybe we have an angle that is 30 degrees. We add to that an angle that is 150 degrees. And these two added up, oops, make 180. So there's lots of different ways that we can deal with supplementaries. So again, from our first picture, measure of angle 1 plus the measure, oops, I got that backwards, sorry. Measure of angle 1 plus the measure of angle 2 equals 180 because you're dealing with adjacent angles. Same thing for the second picture. So I'm actually just going to move that over so it kind of matches up with both of them. Okay, or they could be two separate angles. Sorry guys, a little technical glitch here. Or we could have, again, two separate angles that are not adjacent at all, but 30, just for an example, 30 degrees plus 50 degrees does add up to 180. So those numbers could change, but just so that you could see, For supplementary, your angles do not have to be adjacent. The same thing is true for our next ones, which are complementary angles. So again, any two angles with a sum of 90 this time. So they could possibly be angles that are adjacent. Now, even if I don't know these numbers, I'm going to put in just an angle 1 and 2 here. I don't know how much each one of them are, but look for that right angle box, because if both of these angles can fit inside a right angle, then those two spaces together make up 90, which means they have they are a complementary relationship. So the measure of angle 1 plus the measure of angle 2 equals 90. So they might be adjacent again. And again, the clue here is look for that 90-degree box if they are adjacent. And the other option we have, maybe it's two separate angles, kind of like the one before. Let's use that same 30. And we'll add a 60 to that. Now, these might not be drawn to scale. Again, they're just examples. But 30 degrees plus 60 degrees equals your 90. Okay, so those are some of our main relationships. So now let's take these different relationships and see how we can use them in our problems. All right. So let's see what happens when we start bringing in some problems here. So first thing we're going to do, find the missing measure in each figure. Keep the angle relationship in mind. So what we're going to do is we're going to first look at each one, say what the relationship is, and then that tells me how I should solve this. Because again, if they're vertical, then they're supposed to have congruent measures, so they'll be the same. If they're linear, they need to add up and be 180. And then we've got the idea of complementary and supplementary. So let's look at number 1. All right, so you've got 112 that is in the top space, and your missing x that we need to find is in the bottom space. So they are directly across from each other in opposite positions. So these are vertical, which means they're congruent. So then your x should also be 112. Okay, oops, sorry, moving right along. All right. Now I've got two angles here, 68 and an x. The first thing I notice, they fit inside a right angle, which means these are complementary. Which means a sum of 90. So these two angles together are supposed to make 90 degrees. So out of 90, 68 of that is already gone. So we'll set up our little equation. Our x plus 68 is supposed to make 90 minus your 68 out of that. Sorry, 68, not 66. Because we've used up 68 degrees. And my missing angle is 22 degrees. Okay, moving right along. All right, so this time I've got two angles going on. So let's see what's special. All right, so I've got 124 for my big obtuse, and my x completes the rest of it. And guess what? Together, the two make 180, which means they're supplementary. So a sum of 180 degrees. So let's solve this one. 124 plus my x should make 180. So out of 180, 124 has been used. So we're going to subtract that away. And my x is equal to 56 degrees. All right, so that's one way we can start using our angle relationships. Let's try some with a little more math involved here. All right, so now number 4 has got 3 separate variables to it. So let's see if we can start with 43. Let's see if we can find any that might be congruent. See if we've got vertical angles. So 43 is sitting in the lower right spot. So I need the exact opposite of that, which is upper left, which is over here where the Y is. So these are vertical. So if 43 is in the lower right, go to the upper left, and it's also 43 degrees. So there's the first one. Now, 43 and X, look at their positions. Together, the two of these have to make 180. So X plus 43 should make a straight line. So we've already used up 43 degrees out of my 180. So my X should be 137 degrees. So there's X. And now the beauty of knowing what X is, 137, which is now in the top right position, has an opposite in the lower left. It's directly across from where the Z is. So it should also be 137. That is one thing that I do love about vertical angles. If I can find one, I can automatically find the other angle measure if I know where the vertical pair are. All right, let's look at number 5. Step it up a little bit. All right, so I have a right angle happening here where my box is. So there's 90. Now, this one's a little different. Imagine that the line passing through the middle of this picture, imagine that line isn't there at the moment. Because what I know right now, if I look at this main line that I just colored in blue, this whole set together should make 90 degrees. So out of 180, 90 is already used up. So if I have a right angle on the left side, I should also have a right angle on the right side. So now I have enough that I can find Z, because Z and 72, complementary. So Z plus 72 should also make another 90. So minus our 72, because we've used it up out of 90. And my Z should be 18 degrees. So Z is 18. Now we've got vertical angles happening here. Check out where your 72 is. It's directly across from the Y. So that means those are also vertical. So if the lower right is 72, the upper left is 72. So now I know why. All right, now we need X. Well, check out the top of that blue line that I still highlighted. Together, those two make a linear pair of 180. So then your X plus that 72 that we just found make 180. So I've used up 72, so I'm going to subtract it out. And my X is going to be equal to 108 degrees. So now we found all three. All right, so let's try a few more now that don't necessarily have pictures, but they're giving us descriptions. All right, so we have the measure of 1 and 2 are vertical. So right now that means that the measure of angle 1 is going to be congruent to the measure of angle 2. Okay, so if the measure of angle 2 is 105, find the measure of angle 1. Well, if they're vertical, they're congruent. So then the measure of angle 1 is 105. Let's try the next one. All right, this time we've got A and B are complementary. which right away means our two things need to add up and be 90 degrees. So if the measure of A is 42, find the measure of B. So like we did before, if they're supposed to be 90, we've just used up 42 of that, so I can subtract that away. And the measure of angle B, 90 minus 42 gives us 48, so 48 degrees. All right, let's keep going. This time we've got supplementary angles, which right away says my two things need to add up and be 180 this time. So P and Q are the two we're working with. So if the measure of Q is 64, find the measure of P. So X plus 64 is 180. So out of 180, 64 has been used, so minus it from both sides. And my X is supposed to be 116. So then the measure of angle P, 116 degrees. All right, now to linear pair. Linear pairs, again, are very similar to supplementaries because linear pairs have to make 180. So the two better add up and equal 180. So if the measure of angle 1 is 113, find the measure of angle 2. So again, out of 180, 113 have been used. And my X is equal to 67. So then the measure of angle 2 is 67 degrees. Now, not every supplementary pair are going to be linear pairs, because the difference is a linear pair must be adjacent, while supplementary does not. So just keep in mind. Let's try some algebra, and we're almost done with our examples. All right, so if the measure of angle PQT, so let's trace out those three letters, starting at P, moving on to Q, and then moving out to T is 3x plus 47, and SQR, so let's see where SQR is. S to Q to R is supposed to be 6x minus 25. Find the measure of angle SQR. So we want to know, what is this space at the bottom? What is its total value going to be once we know what our X is? So it's all about where are these located. These two angles are vertical, which means they're congruent. So when we solve this, those equations must be equal. So 3x plus 47 must equal 6x minus 25. All right, and let's solve this out. All right, so you've got variables on both sides, you've got numbers on both sides. I always start with the smallest variable. So that is my 3x, so I'm going to cancel it out. 47 is equal to 3x minus 25. Now we can add our constant back to the other side. So 47 and 25 is a 72, which is still equal to 3x. Divide by your 3. And my missing x is 24. Now we're not done, because again, the question wanted to know how much is the measure of angle SQR. So guys, we need to go back and plug it into our equation. So the measure of angle SQR was 6x minus 25. We know what x is, so 6 times 24. And then take away 25. And that gives us a total of, once we do that figuring, that is 119 degrees. There's our final. All right, second to last one. All right, we've got some symbols here this time. Now, we talked about that upside down capital T in yesterday's video. So that upside down capital T, remember, is your symbol for perpendicular, which means we're going to make a 90 degrees, a right angle. So this says that line AB is perpendicular to ray CD. So this ray that's coming off of that line is making a right angle. And you can think about it, if you have your right angle box on the left, I also have it on the right. So it doesn't matter which side we draw it on, but I automatically get it on both. All right, so let's keep going with our information. So the measure of angle DCE, so D to C to E, that's this space up here, is 7x plus 2. And the measure of angle, let's get the other side here. The measure of angle ECB, so E to C to B, so that's this other space, is x plus 8. All right, so notice those two spaces complete that 90 degrees. So these are complementary, which means I should be able to add the two things up and set it equal to 90. So let's get our two equations in here. So 7x plus 2 and x plus 8 together should make 90. So now let's do some combining of like terms here. 7x and an x, 8x, 2 and 8 plus 10. Make our 90. So let's keep our solve going. So minus our 10 from both sides. And my 8x is equal to 80. Divide out your 8. And my x is 10. Now we're not done because we need to find the measure of DCE. So the measure of angle DCE was the 7x plus 2. And now I know that x is 10. So 7 times 10, and then add 2 to that, which gives me 72 degrees. There's my final. Let's try one more and see what kind of relationship we have here. All right. So we have the measure of angle K in M. So start at K, go to N, out to M. So that's this space on the right. And this is 8x minus 5. All right, then we have M, N, and J, which is 4x minus 19. These space on the bottom. Now, they're not across from each other, so I can't set them equal like we did on the other example, but together, the two of these make a linear pair, which means, like similar to the one we just did, I should be able to add them up and make 180, because linear pairs total 180. Linear pairs are always supplementary. So 4x minus 19 and 8x minus 5 make 180. So let's combine our terms. 4x, 8x, 12x. Negative 19 and negative 5, negative 24 equals 180. Okay, add your 24 back. And 12x is equal to 204. Divide out your 12. And my x is 17. Again, we're not done because it does want a specific measure. So the measure of angle K in M was the 8x minus 5. So now that I know what x is, I can replace it with the 17 and then take away 5 for a total of 131 degrees. And there is our final. So just read your questions carefully, guys, because not always will you have to plug them back in to find the actual value. Sometimes you may just need to find your x. So just pay attention to what the question wants you to find. If all you have to do is find x, then once you found it, you're done, you can stop. But if it specifically says find the measure of the angle, make sure you know exactly which one to plug it back into. All right, guys, I hope you enjoyed learning a little bit about your angle pair relationships and how we can use them to solve out our actual equations. Just pay real close attention to which pairs are supposed to be set equal and which ones you're supposed to add up. That's one of the big things in geometry that we're going to be working on is, do you set them equal or do you have to add something together? All right, guys, I hope you all have a great rest of your day, and please don't hesitate to reach out if you have any questions at all. Bye, guys.